So, today we learned the last bit of the complex numbers for this year, and we learn about the Moivre's theorem. The Moivre's theorem, we already have mentioned it before, that if we have complex number in the polar form z equal r cis theta, then in the polar form it's very easy to put it into the column. That becomes z in the power of n equals I in the power of n cis n theta. So that's the Moivre's theorem. And it is very helpful in solving and finding the roots of the complex numbers. For example, we need to solve equation z in the power of 4 plus 16 equals 0. So first, let's write it as z in the power of 4 equal negative 16. Then we need to turn negative 16 into the polar form. So what will be negative 16? You even don't need to go through the process finding the through the process of converting from the Cartesian to the polar, because if you look on the Argand diagram, negative 16 is here. So what the modulus will be? 16, and what the angle?
0.
Angle, we from measure angle from here.
Oh,
Angle will be pi. So negative 16 equals 16 cis pi. Because cos, if you substitute here, what is cis? It's cos pi plus I sin pi. Sin pi is 0, cos pi is negative 1, we get negative 16. So, let's now, how we solve this equation, z in the power 4 equal negative 16. Let z equals r cis theta. Then z in the power of 4 will be r in the power of 4 cis 4 theta, according to the Moivre's theorem. So we can write r in the power of 4 cis 4 theta equal 16 cis pi. Make sense? How we got this? We solving z in the power 4 equal negative 16. We turn negative 16 into the polar form, this 16 cis pi. And we say let solution of the equation is z in the polar form r cis theta. Then what will be z in the power 4? According to the Moivre's theorem, it will be r in the power 4 cis 4 theta. Make sense? Now let's solve this equation, and we break it in two parts. We solve in for r and solving for theta. So we have r in the power of 4 equals 16. So r equals 2. Remember, r modulus is a distance, so it's always positive. It cannot be negative 2. R is a modulus, it's a distance. Distance cannot be negative. And then we need to solve this. We have cis 4 theta equal cis pi. So what will be the solution? 4 theta pi. That's all.
But there's another solution from the domain.
Plus, how we solving plus 2 pi n.
Because from negative
plus 2 pi n.
Is it still the argument?
We will at the end we'll see if our solutions fit into the domain from minus pi to 1. So what theta equal from here equals pi on 4 plus pi n on 2. Pi n on 2. And let's consider which of them, because all our solutions must be in the interval from minus pi to pi. Take n equals 0, we get theta equals pi on 4, n equals 1, what will be theta equal? 3 pi on 4. If you take n equals 2, we get outside, we get number greater than pi, so we stop here. Then we take n equals negative 1, theta will be equal negative pi on 4. We take n equals negative 2, we get theta equal negative 3 pi on 4. So we got 4 solutions, and it always in the complex numbers, when we find in 4th root, it has to be 4 solution. If the 5th root, 5 solution. Cubic root, 3, always what the power is, that many solutions. So let's write all those solutions first in the polar form. Does all make sense, what we did? So we have, in the polar form, we have solution here, we have 2 cis pi on 4, we have 2 cis 3 pi on 4.
Why 2? Where's the modulus 2?
Because we have that modulus in the power of 4 has to be equal 16. That means modulus equals 2. And modulus must be positive. We cannot take negative 2 for distance. We have 2 cis negative pi on 4. And we have 2 cis negative 3 pi on 4. Let's put those solutions on the Argand diagram. And we see they all have same R2. So they will be on the circle, not the best circle. Let's assume that it's a circle. They all on the circle with the radius 2, because they all have modulus 2. And how they position? Pi on 4, 3 pi on 4, negative 3 pi on 4, and negative pi on 4, negative 3 pi on 4, 3 pi on 4, and pi on 4. So they are on the same circle with the same radius, and they evenly spaced around that circle. They even, and that always will be the case. If there will be 3, power 3 and 3 solutions, so here what angle we have between all of them? What angle we have? Pi on 2. If there will be, if we will have z in the power of 3 solving equation, what will be angle between the solution? 120 to pi on 3. If it will be like in the power of 8, there will be pi on 4. 8 will be 8 solutions positioned on the circle with the end between them. Yes?
So what did we just solve?
We solve the equation z in the power of 4 plus 16 equals 0. We found 4 solutions in the polar form.
In the polar form.
Yes. And that was question on the past 3-4 exam, but it's asked to give your answer in the Cartesian form. So had to, let's do one more step and turn those solutions from the polar form into the Cartesian form.
How many marks is this?
It was 2 marks.
What, for all this work?
Yeah, it was 2 marks. It's special. It's special. It's supposed to be smart kids doing it. So, can you turn 2 cis pi and 4 into the polar form?
2 cos pi 4 plus I sin pi 4.
So what it will be?
Root 2 minus root
2 times
root
cos pi and 4
Wait,
plus I sin pi
yeah,
and
root 2
4.
plus root 2 on 2.
Mr. B, is that meant to be a round bracket against, like, with a negative pi?
Doesn't matter because we're never like we can reach it.
No, the thing is, if you look on this point, yeah,
Yeah,
if you got pi,
yeah,
yeah, minus pi at the same point,
yeah. So,
you're not counting the same point twice.
like, why do you pick pi? Why don't you not count pi?
Because pi is positive. Let's be positive, people.
Yeah.
No, because if I will write, for example, 2 cis pi and 2 cis negative pi, is it a different point? At the same point. But we should have that when we define it, it has to be 1.
Okay.
That's why we need to choose a the minus pi included or pi included.
So would it be wrong, or would I lose marks if I write negative pi?
If you give your answer like this instead of this, yes. Yes. So, back to this, we get 2 times root 2 on 2 will be root 2 plus I root 2. What will be the next one? Can you tell me straight away? What will be this one? This one solution? What will be this?
Negative root 2 minus
Negative root 2 plus
plus.
I root 2. Next one,
That will be root 2 minus I.
that will be root 2 minus I root 2. And the very last one will be negative root 2 minus I root 2.
Yeah.
So we have found 4 solutions of the equation z in the power 4 plus 16 in the Cartesian form.
So what do we have to do? We have to do that, then z
You need-
equals negative 16.
You need to write z, if you solve an equation z in the power of n
Yeah.
plus, or let's say minus z1
Yeah.
equals 0.
Mm-hmm.
You rewrite it as z in the power of n equals z1. Then this one we always write as r in the power of n cis and theta, because that is the Moivre theorem, that complex number in the power of n in the polar form is this. Then we turn this into the polar form z1. Let's say I will put, let's say we get A, cis, beta alpha. No, so not mixed up alpha, we do alpha, cis, beta. So we turn Z1 into the polar form, and then solution will be the R will become,
n equals a and
we
n.
will have that R equal nth root of A,
Mhm.
and only positive, we take only positive solution because, and then we'll have n theta equals beta plus 2 pi n. Sorry, yeah, not 2 pi n, it has to be different
Yeah,
number.
k.
2 pi k, and then theta will be equal beta over n plus 2 pi k on n, and you try k equal 0, plus minus 1, plus minus 2, until you stay in the interval minus pi to pi.
Would it always be that interval? Depends what they ask.
It's always because that's a principal argument.
Okay.
Everything else will be repeated. In from minus pi to pi, we have covered the whole revolution. Make sense?
Especially,
Yes.
do you have to write like k as an element of an integer, or is that not?
No, you don't write that I gave you. You need to check.
No,
You
obviously,
take k
but,
equal.
like, would you have to write next to a general solution anyway, especially k as an element of an integer, like to get marks?
You don't have to find general solution
Okay.
in the complex number. You need to find the
The answer.
actual solution. You need to find the roots of the complex number.
Okay.
So you don't need that I write to you. So how you find it all solution? You take k equals 0, see what you got. K1 minus 1, 2 minus 2 until you stay in. As soon as you get out of this interval, you stop. You found all solutions.
Okay.
Make sense? Like, subscribe, and donate to help fight terrorist countries and organizations, support Ukraine and Israel.